Here's a quick demo of my new motor control design. This is also the brains of my electric bike. So this is a printed circuit board PCB I designed with the MOSFET transistors, high voltage capacitor, flyback diode, 5-volt power supply. This is a pickaxe programmable brain, or SBC as I like to call it. This is the indicator light telling you whether you're in a normal mode, and then fill up these prototyping areas for custom needs that other users may have, such as just hooking up whatever you're doing, Tesla coils or whatnot. This is for your general experimentation. So this is a wheelchair battery. My digital multimeter here. I'll turn the throttle off so you can see. Running 0 amps. Motor's off, so I'll increase my throttle about quarter of the way into the throttle here. And in a no load situation, that puts us at 0.8 amps. So blinking away, she's happy. You can watch what happens as I go ahead and put a little load on this motor. You can watch how this reacts and how DC motors work and why they're so useful. As I put a load, it jumps from basically 3/4 of an amp all the way up to 2 or 3 amps. If I really jam on it, you get 5 amps. So changes from 10 to 50 watts based on load. Here at 10% throttle, I'm going to increase the throttle. Here it's checking about 4 times a second where the throttle is. I do that instead of continuous because it's a little better for lifespan and a couple other reasons. So now, here at about half throttle on the 12-volt battery, you can see it's a static 12 watts again, but when I stall it, it jumps right out to 3, 4, 5 pretty quickly. So that right there, it's really only running 50 watts, which is quite impressive because this thing's making about 4 or 5 foot-pounds of torque. I expected it to be running 500 watts under that kind of situation easily. So now I'll go ahead and increase the throttle up all the way. And here it just goes full on because that's a lot more efficient. And still we have the same no-load speed. Here the stalling it goes up at a much more rapid increase in current, and I can't install it very effectively, but it'll jump up to 10 amps. Yeah, about 100 watts. So running 36 volts through this, due to the exponential relation of voltage and current, you will get approximately exactly 1 kilowatt output from this motor instead of a couple hundred watts. And this motor will do 3,000 or 4,000 RPM at 36 volts, which is what I'm planning to run on lithium. So you can get the basic idea. Here's another feature. Right off the top of the chipset here, there's a few pins where you can attach a thermal sensor. It looks like a little... It basically will shut the motor off if it gets hot. I don't have that hooked up because none of it's getting hot right now with the low voltage test setup. And yeah, there you have it. This is a very nice system. Hope it makes many users happy with their various low budget, high power devices. Thank you.